All right, we'll move on to number 3 here. So let's approach this first by figuring out if we have a excited state, figuring out whether we have an allowed or forbidden electron configuration first. So let's do this as a little flow chart. Okay, so out of all possible types of orbital diagrams, they are either going to be allowed or forbidden. And then if it's forbidden, there's actually not any, it's not worth saying anything else about it because that's not anything that exists. But if it's allowed, there's going to be 2 different kinds that we can have: a ground state and an excited state. Okay, this ground state is going to have all the electrons in the lowest energy configuration, and then the excited state will have 1 or more electrons not in the lowest configuration. So let's approach these 4 this way. And I'll show you basically the 2 ways with a line diagram that I can make something that's forbidden first. Okay, well here's one of the 2. Okay, you might notice all of these boxes have either 1 or 2 or no electrons in it, except for this weird one here. Okay, this has got 3 electrons in it. And this is a forbidden state. The reason for this is this has 2 up electrons, and that's what causes this to be forbidden. I have 2 up electrons in that same box. So this one's forbidden. And if I search around here somewhere, I bet I'll find 1 more forbidden state. So I'm looking around, and also this pokes out at me. So actually, in a lot of ways, this is the same problem. There's 2 up. So if we're talking about if we were talking about that m sub s value, both of these would be m sub s plus 1/2. And so that's what causes this to be a bad situation. We've got 2 electrons in the same orbital, both pointing up. So this is the bad situation here, and so that one's forbidden. All right, all the rest of these are allowed. So what makes them allowed is that they have 0, 1, or 2 electrons in each box. So 0, let's do this one. 0, 1 electron, or 2 electrons in each box. The box can fit up to 2. Is what makes them be allowed. Now we have to decide if whether the energy is okay, whether we could have a lower energy state. So let's jump down to C here first, and let's kind of work this backwards. So we've got 1, 2, 3, 4, 5, 6, 7. We've got 7 total electrons. And the way we fill these, like when we filled these box diagrams up here, we go up, down in the first box, up, down in the second box, and if we look up here, this is analogous to this situation. So we should go up, up, up before we put any electrons down. So this is actually the best way we can do these. So this is a ground state. Well, if we try to do the same thing up here, 1, 2, 3, 4, 5, 6, 7, 8, well, that's okay for it to have 8 electrons. But what's not okay is we should do 1, 2, 3, 4, and that used up 4, and we've got 4 left to put into the diagram. And then we should go up, 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 and then the ground state of this should actually look like this. Okay, that electron should not be over there. It should be paired up in the 2p box. So this is an allowed state, but it is an excited state. Okay, an excited state does get to exist. So if we took the ground state and we heated it at really high heat, or we hit it with the right wavelength of light, we could cause this to exist. It could have a short lifetime, it could have a relatively long lifetime, it could exist. Whereas these forbidden states don't exist. No matter what we do, we can't prepare a forbidden state even for a second.